let's continue where we stopped.
Question number 5.
Number 5, I think. Yep. Let's go there.
6. Huh?
Yeah, we're going to number 6 now.
Yes. 6 is over. Maybe going to number.
Okay, so May. Okay, May, you can do number 6. Number 5.
5 is over.
Let me increase this a little bit. Oh, 5 is done. Okay, May, number 6.
I think 6 is done.
No.
No.
From 6 you have to start.
Yeah. This question refers to.
Oh, okay. This is about. There is an exercise. But 1 second.
Configuring a small office.
Yeah, that is. It's like right here. There's something that he did here. Configuring this one right here. So yeah, it's like when you set up your wireless router, you have to plug in the cables, change the SSID. It says change the network password to something difficult to guess. Okay, so then they give some passwords. So yeah, let's keep that. That's just like you have to like read this task, right? And then you'll be able to answer the question. So you know what I mean? So let's just move on. Okay, well, May, try number 7 then.
Your friend Maria asked you which router feature provides for a guaranteed bandwidth. What do you? Oh, I can see.
Okay, well, let's look at this. Yeah, let's look at this. Which router feature provides for guaranteed bandwidth? So, first of all, we know that it cannot be DNS. It cannot be DHCP, right? So, it's got to be one of these two guys. So let's see. Control F. Let's just be sure anyway. Okay, so bandwidth. Is that the first occurrence of bandwidth? All right, so look at it here, May. So these are features, right? These are features of routers. If we go up here, yeah. So router services, the different things you can do on the router, okay? So we already talked about guest access, right? We talked about this already, guest access. We talked about DHCP. We talked about network address translation, right? If you recall, allows you to use private IPs, and then it converts it to a public IP, all right? So QoS is the next one here. That is quality of service. Quality of service. It allows an administrator to control resources to maintain a certain service level. So if you're the administrator of your network, it says you can right here, you can set different priorities for one or more types of network traffic. So basically, you can determine what kind of traffic, you want to operate at different times, right? The whole point is, it says right here, for example, let's see, if the engineering group needs to have a certain amount of guaranteed network bandwidth, quality of service can make it happen. So it looks like quality of service features, right, is a set of resources on the router that the administrator can control, right? So it might be, let me remove all this stuff here so you can see that again. So right here it says, types of network traffic. Where is it? Types of network traffic, right? Yeah, you can set different priorities. You know what, May? What is the, what priorities are? Like, what happens first? What happens next? Right? You can delay a service so that another service can work. So like number 1, number 2, number 3, different priorities, right? So it's saying that based on that quality of service features, you can decide that maybe the engineering group you can give them guaranteed network bandwidth, right? Now, so the question is, what do you mean by guaranteed network bandwidth? What does that mean, right? What does that mean, guaranteed network bandwidth? So I'm going to give you some background. So let's look here, guaranteed network bandwidth. So let's talk about hubs. So what's a hub? Here's a picture of a hub. Okay. Yep, this is an example of a hub. Has anybody seen this before? Or you have this at home somewhere? Long time ago, maybe? Has anybody seen this device before?
I think I saw it.
Where is that?
At my home.
Oh, you have this at home?
Where we connect the net.
Okay, you connect to your internet and everything, right?
Yeah.
Okay. Well, the one you have at home looks like this, but it may not be exactly like this. Here's what I mean. So, in the early days of computers, we had devices that looked like this, and you call them hubs, right? So what is a hub? What are the features of a hub? Some of the features of a hub include what we call bandwidth sharing. Now, what is bandwidth sharing? So here's an example. Let's say you have, I don't know, 100. Let's just keep it simple. Let's say we have 100 bytes of data, okay? In your network, you have 100 bytes of data. If you're connected to a hub, right? This was like a long time ago, not right now. If you're connected to a hub, long time ago, you're using a hub in your network, and you might have 100 bytes of data available to all the employees or people at home. So here's what happens. So you have one person here, first person. Let's just give them a name. Let's say Jane, right? Jane comes to work and puts on her computer. When Jane puts on her computer, she's going to have 100 bytes of data. Then the next person comes to work, right? Let's say this is Lee. When Lee comes to work and puts on his computer, because the hub, right, the hub has this bandwidth sharing. What happens is now this is going to be 50 for Lee, and Jane is going to come back, it's going to become 50 because they have to share what's available. If one more person, let's say, you know, Greg comes to work and Vic comes to work, right? They all show up at work. What is going to happen? You're going to share the 100 bytes of data with all these 4 people. Now it's going to be 25, 25, 25, 25. So here's a question for you. When Jane had 100, right? When Jane had 100, is Jane going to be fast? You know, like Jane is working, Jane is going to be faster, right?
Yes.
But now, Jane is going to be faster, but now, every time somebody else comes to work, right, and everything starts to reduce. It starts to reduce. In fact, if you have more people coming to work, let's say now you have so many people coming to work, right? Now you have Jay, you have Shen coming to work, you have Ahmed coming to work, you have Tom coming to work. Well, what's going to happen? Maybe it's going to be like, who knows, 2.5 for each person, 2.5, 2.5, something like that. It's going to reduce for everybody. Now, what happens when the bandwidth reduces? Everything becomes so slow for everybody, right? So slow. In fact, this technology for hubs, that is how wireless works today. Wireless services, right? It has a lot of bandwidth sharing. Wireless services. So if you're in a wireless place, and the more people that are in that wireless environment or network, the slower it is for each person. That's how wireless works. There's bandwidth sharing, right? You share the bandwidth. Of course, you have to solve the problem, you have to increase the amount of data for everybody, right? If you increase like a lot for everybody, then there's not much of a problem. But basically, that idea of bandwidth sharing, that's just how the hub used to operate. Something else that the hub does, let me just take out this here. Something else that the hub does is, we say, let's call it data sharing. Now, what does data sharing mean? So look at this hub here. Let me say network hub device. Let me show you something else here. Okay, let's use this picture. All right. So, Lynn, how many computers are connected to this device?
How many? One.
One computer is connected to this device?
4.
And Juran, how many?
If that is 4.
4.
4. No.
There are 4, Lane.
Yeah.
The yellow cable, the white cable, the green and the red cable. So when you plug it to this, when you connect to this this end, where is the other end? Where does it connect to? Like the other side, where does it go?
Your
So
computer.
here is exactly. So here's the cable, right?
Yeah.
You connect one end of it to, let me just pretend, right? Like this is the device. You connect it here. Well, what of the other end? The other end goes to the computer, right?
Yes.
Okay. So how many computers are here? You can say there are 4. You understand?
Yeah.
So Lynn, why did you say 1?
Because before I never see the orange one, the blue, green one, red one.
Okay. So there are 4. Okay.
Okay.
So when we talk about data sharing, right? Let me just try to explain it to us here. So each of these wires is bringing in information, right? The yellow cable, the white cable, the green cable, the red cable. They're bringing information from your computer to the hub, from the hub back to your computer, from your computer to the hub. When information comes into your house, for example, it goes through this hub and goes to all the computers that are connected, right? That's how it works. So the hub, what the hub does, this was like a long time ago, data sharing. Every time a message comes into this hub, the hub doesn't know who owns the message. It doesn't know because the hub is not able to read the data, what we call read the data, right? Cannot read data. The hub cannot read data. So it sends the information to all the computers that are connected because it doesn't know who owns the information. It just sends it to all the computers that are connected. It's like, let me see if I can help you guys understand what I mean. So, Couch, let me go to Couch. So, Couch, do you get, let me see. Let me get a picture here, just to help you guys understand what I mean. Okay, so Couch, you get mail coming to your house, right? A mail carrier brings mail to your house?
Yes.
Okay, so when they bring the mail to your house, do they have duplicates of the mail and they give to your neighbors the same mail that they give to you?
No.
You know what I mean?
Yeah.
Like they have, like let's say you have 10 neighbors. They give you all your neighbor's mail, then they go to your neighbor and give everybody's mail to your neighbor, give everybody's mail.
No.
I mean, imagine that, right?
Yeah.
Alex is looking like, what? What are you talking about? You see, you can't imagine that. I mean, your own mail only comes to your house, right? Well, once in a while, maybe, the wrong mail, but that's not very common. Your mail comes to your house. Your neighbor's mail goes to your neighbor, right? And that's how it works. Because now, how does it work? Why does it work like that? Because your mail has your address. Your mail has your name, your address. Okay? So there's no confusion. Okay? So the mail carrier is able to read the mail and know, okay, this mail is for Couch, this mail is for Alex, this mail is for May, and everybody gets their mail. So there's no confusion. Now, with the hub device, well, that wasn't happening with the hub device. The device doesn't know if it's the yellow cable that belongs to Alex's computer, or the white cable for Lynn's computer, or the green cable, or the red cable. It just sends all the data to all the computers that are connected to that hub. Now, do you see a problem with that, Alex? What kind of issues do you think will happen if that, with that kind of setup?
If you have a file or anything that you want to share to a specific user, you will not be able to do that.
So there's no privacy, right? Privacy or even security of your information, right? And of course, well, let me get this out of the way. Security. What of things like time wasting, right?
Yeah. Storage.
It's not your mail. It's like junk mail, right? When you get junk mail, you have to go through everything and like, okay, this is not mine. You know, this is not mine. You throw it away. You throw it away. You throw it away. You have to spend so the computers have to spend a lot of time saying this message is not mine. Get rid of this. Get rid of this. Right? That's how the hub operates. Not very efficient, right? So it had bandwidth sharing. It shares the bandwidth, so it can be very slow for everybody. That it cannot read the data, so it's like spam when you get emails that are just for everybody, right? That's how those devices operate. So with time, right? We kind of moved forward from hubs to what we call switches, right? Switches, or a switch, right? Switch, W-S-I-T-H, a switch. So a switch looks like a hub. That's what Anu says that she has. That is a switch looks exactly like a hub, right? I mean, it's basically, you know, it looks exactly alike, but the technology is different, right? Also, you actually have switches that are much bigger than hubs, right? So when you go to a company or you go to an office, you might find, you know, switches, something like this on a, you know, in a computer room, you might find, you know, switches with a lot of computers that are connected to it, like a lot. I mean, here there are a lot of examples. Here's an example. You're going to find switches that have hubs, a lot of computers, right, connected to them, right? They're just very big, like a little bit bigger in some cases than hubs, or sometimes they are just exactly the size of a hub. For example, you know, here's a switch, right? Here's a switch. It looks like a hub, right? Now you see what we call, you see this holes that you plug, that you connect the cables into. They're called ports, right? They're called ports, right? You connect the cable into a port. All right, you connect the cable into a port, and the ports have numbers. Okay, so if I can show you very closely, you can see. Yeah, you can see. I think you can see this one, right? If you can see it at all, you're gonna notice that each of these ports, they have numbers, right? 17, 8, 19, 21, 23, 18, 20, 22, 24. You're gonna see, you know, this is one switch, this is another switch here, 17. They all have numbers, all right? They all have numbers. Those numbers, right, port numbers, right, are part of the address. So when you connect a cable to a port, the switch is what we call a smart device. Smart device. It's much smarter than a hub, right? Much smarter. So port numbers. So the switch, first of all, the switch can read the data, right? It can read the data. It can read the port number that the cable is connected to. So it knows where to send it, right? It also reads what we call the MAC address. The MAC address. What's the MAC address? When you go to your command prompt ipconfig and you do ipconfig/all, right? If you look at the very top, you're going to see it looks like hexadecimal numbers. So it's something like this here. Where's my, this is it right here, right? 02, well, everybody has a different MAC address, okay? So your MAC address is going to say physical address, right? Physical, same thing, physical address, MAC address. Now, what is this address? Where do you get this address? So you guys might remember oh, NIC card. Okay, you guys remember this, right? Oh, that's too small. Do you remember this device?
Yeah.
What's that?
Network,
What is it?
network interface card.
Exactly. This network interface card, this example, you connect it inside your motherboard, inside the computer. Okay? And this end of it here is where you connect your Ethernet cable. Now, this network interface card was manufactured by somebody. Somebody produced it. So in my example, if I look closely, I might find my manufacturer here of my network interface card right there. Okay, actually, this is it right here. Right here. You can see the description, right? Is made by a company called Realtek, right? Realtek, and this is the MAC address, right? Now, this is important. Why is this important? It's important because, first of all, the manufacturer of your NIC card, of your network interface card, right, gives that network interface card an ID. The ID, so to speak, the ID is the physical address or the MAC address. So Realtek, that produced my network interface card, gives it an ID, and this is the ID. Now, so let me show you something here. Hopefully you guys are not confused, right? So an IP address, right, points you to somebody's zip code. If you can find the IP address, you can find the zip code where a computer is at. The MAC address or physical address right? The MAC address or physical address, right? It's kind of like a house number. You can compare it to that. So if you can find an IP address, you can find the geographical location of a device or a computer. If you can find the MAC address or the physical address is attached to the NIC card, and that NIC card is installed inside that computer. So if you can find the MAC address, you can be more specific and probably find the computer that's sending the message. So the IP address will take you to the area where that, device is or computer is, but the MAC address, right? The MAC address is attached to the network interface card. The network card is installed inside your computer. It's a physical device. So if it is possible to find the MAC address, then it's possible to find your computer exactly where it is. Am I making sense to you, Arch? Do you understand what I'm saying? Or are you guys totally confused? Like, we don't know what this guy is talking about today. Arch, how does this sound to you? Does it make sense? Art, you're muted.
Yes. So it's
So does it make sense?
Yes. What is full form MAC? MAC means?
Oh, Mac. Let's go back to the book here. Let me show you what MAC means. M-A-C. So right here, let's go and look for it. Okay, that's what it means here. So the MAC address is media access control. Right here. Media access control, which is the physical address built into the network card. Right? It's built into the network card. So that network card is physically installed in your computer. So if I can find your MAC address, maybe I can be closer to finding that computer exactly where it is. So, so the ports, so the switch, right? The switch device, the switch, you know, it can read, like I said, it can read data, and the kind of data that it can read all these things here, right? It can read the port number, it can read the MAC address, right? And that's how the switch is able to direct the data to your computer. It doesn't share it all over the place. When the data is flowing, right, when the data is moving back and forth, the switch can read the data. It can look at that information and look at the port number. It's like, you know, the mail carrier. When the mail carrier is moving around, where's our mail carrier picture? Where'd it go? It disappeared. Okay, that's our mail carrier. When the mail carrier is going to deliver mail, Arch, he can read that information. He says, this is for 110 Main Street. The next one, 111 Main Street, 112 Main Street, 113 Main Street, right? It can read all the information and send that letter or that package to the right place. That is how the switch operates, right? The switch can read the port number and the MAC address, and so it knows where to send that information. So the switch does not do any bandwidth sharing, right? Does not do bandwidth sharing, right? So in our example that we had before, in this example, when Jane comes to the office and Jane has 100 bytes of data, when Lee comes to the office, how much data does Lee have? Using the switch, how much data does Lee have?
Zero.
What?
0? 100.
No, we're talking about the switch now, right? The switch. So the switch does not do bandwidth sharing. No bandwidth sharing. So when Jane comes, Jane has 100. When Lee comes, Lee has how many?
100.
Exactly. When Peter comes, right? What does Peter have? 100, right? Everyone has 100 because there is no bandwidth sharing. Everyone in the office has 100. Everyone has 100, right? That's how it works. Everyone has an equal amount of data available to them using the switch, right? So there's a lot of benefits that the switch has over the hub. In fact, you're probably not going to see hubs around anymore, or very few places, right? Because there's a lot of problems with the hub. And that's why, you know, that's why they switched to a switch, right? Because the hub wasn't so efficient anymore. All right, so I had to explain this so you know some of these terms. Bandwidth sharing, it just means that the available bandwidth is being shared by all the devices. And so everything becomes a little bit slow. But with a switch, which is what we have today, everybody can operate at the same efficient bandwidth level. So if you get, for example, if I look at my computer, I look at my network status here, and my Ethernet, you can see that my Ethernet is 100 megabits per second. Well, every device in my house is going to operate at 100 megabits per second. Same speed, right? Now, the speed of wireless is different from the speed of Ethernet. Right now, I'm on my computer. I'm connected to a wire. When you're on your wireless, you're going to notice that your wireless is a bit lower than your desktop computer, for example, because there's so many variables that affect wireless. Like the weather can affect your wireless, electricity, a lot of interference, right? There's a lot of interference that can affect your wireless. Even the distance, right? If you're too far away from your router, you might have some problems too with your wireless. So wireless has a lot of issues, right? They're always trying to improve it. So your wireless is not going to have the same speed. In fact, if you look at your wireless, this number is going to be changing. It's going to be going up and down, up and down, up and down, up and down, up and down. Does anyone have anyone on their computer right now on a laptop?
Yes.
Couch, you're on a laptop?
Yes.
Okay, so go to your control panel and let's see what you have. Go to your control panel and let's see if we can get some information. I'll go to your network and internet, and then let's see your network status and task. You're looking for your Ethernet here. If you look for your Ethernet, then look at the speed of your Ethernet. You might see that it may not be so stable. So, do you see it? Anybody? May? Do you see your... Okay,
Yeah.
May, you see it, right?
Yeah, but
So
I connected with Wi-Fi for my laptop.
Okay, so what's your speed? Can you see your speed?
Yeah, let me see. Hold on.
Yeah, if you look at your speed, you might notice there's a difference.
Like
What?
130.
Your speed is 130 on your
But now
wireless.
it's 104, so it keeps moving.
Okay, it keeps going up and down, right?
Yeah.
So that's how wireless is. It's going to keep going up and down. Okay, anybody notice that too? Anu, do you notice that?
Yeah,
Go
I
ahead,
don't know where
Kaush.
to,
500.
in control panel, what to search, what to click
Slow
on.
down, stop. Kaush, talk to me, Kaush.
Now 650
Okay, so 650 what?
megabytes bytes per second.
Mbps.
Megabits per second.
So it
Now-
keeps going up and down, right?
Yes, now 585. It's
Oh, it's going to keep going down all the way to 0?
526. Yeah, it's changing. Oh, now
Yeah, so
700.
that's how wireless is. Wireless is a bit unstable, right? But if you're connected to the wire, like directly, maybe from your laptop, if you grab your laptop and you connect your laptop to your router directly, it's going to be stable, more stable, right? More stable. So, okay.
Professor, where I have to click for that information? In
Go to your control panel,
Yeah, then
then go to View Network Status and Tasks.
view network status.
Under Network and Internet.
I don't have that. I don't know.
Okay, maybe yours is, do you have this option here, View by Category?
View by category.
Someone is behind you, Anu, trying to hide.
Yeah, my son. I don't know. I will see later. No problem. I'm disturbing the
Okay,
class.
you know what? Type it here. Type it here. Type
Oh, okay.
type status. I think status.
Yeah.
If you type status, then it should show you view network status and tasks. STATUS.
Yeah, status. I found security and maintenance window, defender, firewall, network and sharing center.
Yeah, right here. So network view network status and tasks under the network and sharing center.
Okay. Oh, got it.
All right. So you should see Ethernet somewhere here to the right, or Wi-Fi or something.
Yeah, it's showing me a name of the Wi-Fi, but no.
Yeah. So click on it. Yeah, click on it.
Oh, okay.
Click on it.
Okay. Got it. Speed
So what's
is
your speed?
195. Changing. It is now 260 Mbps.
Yeah, it's gonna go up and down, up and down, up and down like a yo-yo.
Yes. Got it.
Okay. All right. So let's move on. So I just wanted to explain to us, when we talk about bandwidth sharing, right? What that refers to.
Professor, what is that mean duration in that? The
What?
Wi-Fi status, there's a duration 4 days like that. What does that mean?
Let me see what you mean. 1 second. Okay. Oh, you mean like here?
Yeah. Yes.
I have no idea. I don't know what it means. I don't have, I'm like, okay, how many days do you have on yours? What does yours say here?
4. I have 4 days.
4 days. Maybe 4 days to the end of the world. I don't know what it means. I'm just kidding around. I'm not sure. I'm not sure. Duration. Oh, Lynn has 3 days.
Yeah.
Maybe in 3 days, your computer is going to shut off. Like, no more computer for you. No more internet. or maybe 3 days to pay your bills. I don't know. I don't know what it means. So let's move on.
Excuse me, Brenda. I have one question.
Sure, go ahead.
Like when we connect the computers with using the switch, will it share the IP address, or each one have their own address IP?
Okay, when you connect using a switch, you said, do you share IP address? Is that a question?
Yeah.
You can never share IP. No. Every device has its own, unique. Every IP is unique. IP addresses are always unique. Always unique. You can never share IP with another device. Never.
Using the LAN connection also?
What do you mean?
Like
what's the LAN function?
LAN, local area network. Connecting together, like without Wi-Fi.
I am totally lost, Arch. I'm totally lost with your question.
I want what's the
Try
difference
again.
between
Try
router?
again.
Yeah, like a router and a switch. Will it?
Okay.
Yeah.
Okay, if I understand your question, so maybe I understand your question. So every router, right, has an IP, right?
Yeah.
Your router's IP is like your zip code, right? It's like your zip code. So where do you live, Arch? What's your zip code?
01960.
Okay, where's that?
Like
is that
Peabody.
New York?
No.
Oh, that's in Peabody.
Yeah.
Okay, that's in Peabody. Okay, so in Peabody, in your zip code, do you share the zip code with other people?
Yes.
Exactly. So all the buildings in that zip code have the same zip code, right? But MAC address is like your house number, like we said before, right? It's like your house number. Okay. Do you share your house number with other people?
No.
It's just your house number. Okay? So the IP address, okay, let's be clear, right? This is the public IP address, right? The public IP, right? The public IP is shared. So public is shared, right? But now you have a, like you have a private IP, unique, not shared, right? So your private IP for your computer is unique. In fact, last class, when we looked at the different classes of IP addresses, right? The different classes, we looked at, let's see, class A, right? Class B, and class C, right? 10 to what? I forget what it is. 10 to 127, something like that. 128 to 196. I might be wrong. I don't remember. It's too many numbers in my head.
191.
Oh, 191. Okay.
Yeah.
Then class C is 192
to 223.
Okay, something like that. Okay. So all this, all these addresses, you're gonna find them. You're gonna find them as, the different classes of IP addresses, right? Now, this is actually a way to make computers, or should I say, it's a system that helps us manage the IP addresses, IPv4 addresses, right? So you can find that, for example, my computer, my IP address right here, where's my IP? So this is my IP address, right? Now, if you look at your IP address might actually be the same number here, 10.0.0.112. Because I'm in a different network, and you are in a different network, so you can actually use the same number. It's like, it's like this address, right? Say 12, I hope this doesn't confuse you guys. 12 Main Street. Okay, so where is 12 Main Street? What town? What town is 12 Main Street?
You didn't mention.
Okay, but where, okay, do we have Main Street in Quincy?
Maybe, yeah.
Okay, what of in Peabody?
No.
No.
What of Somerville?
Yeah.
What of Cambridge? What of,
Boston.
do we have Main Street in Boston? What of Watertown? That's where I live. We have Main Street in Watertown. I'm sure every town has Main Street.
You could try asking what town doesn't have a main street.
Exactly. What town doesn't have it, right? So every town has it. But you see, what makes me different if I'm at 12 Main Street and Couch is at 12 Main Street, what makes it different is I might be in Watertown and somebody else is in Quincy. The same kind of address, but a different zip code. So when you think of your private IP addresses, right, you can have the same private IP, but your public IP is different, right? Okay, we got to move on. So hopefully, that helps you a little bit. I mean, we spend much more time of this in a regular class, much more time on this topic in a regular class, but I'm just trying to give you guys some kind of idea so that when you see it in the exam, you won't be totally surprised, like, I have no idea what this is, right? Okay, so back to that question now. Let's see if we can figure out, well, I think we already solved it, May. Question. So, May, do you know the answer now? I'm sure you do, right?
Yeah, D, QoS.
QoS. What does it stand for? What does it mean? What?
Quality
You
of
you
service.
forgot?
Quality of
Quality of service.
Mhm.
Exactly. Quality of service. Okay, Alex, number 8.
One of the following addresses is considered a private IP address.
So did we talk about private? Let me just talk about it a little bit more, I think. Just to give you, just to be clear, I think I tried to mention it. Okay, so let's see. All right, so this is the range here. It's actually what we talked about already, but so right here are your private IP address ranges. So when we compare to what we did here, so amongst all these classes, right? Amongst all these classes of IPs, the first range there, 10 to 127. In that range, you have, let's see, you have 16.7 million hosts. So you're going to go from 10.0.0.0 to 10.255.255.255. So mostly, you can conclude that any address that starts with 10, right? Any address that starts with 10 is a private IP address that you can use at home, like what I have, right? Like what I have here. This is a private IP address. So any address that starts with 10, okay? 10.0.0 all the way to 10.255.255.255. Then the next range is going to be in the B range. So 172.16.00 to .31. So it gives you about 1 million. So so that's class B. So the first one is class A. Then you have class B. You have a few of those in class B, and then class C, which is right here, right? You have about 65,536. All right, so those are private IP addresses that can be used by, local area networks. It's not part of your public IP. So like we said, when we looked at addresses 110 Main Street, every network can use this private IP addresses. There is no conflict. Makes a little bit of sense, Alex?
Yeah.
Yeah. It's like when you go to a town, you're going to see some street names that are very common. You're going to see Highland Ave. You're going to see Main Street. You're going to see Spring Street. You're going to see, like every town has the same kind of. It's like they don't have any new ideas for street names, right? Stuff like that. So this will give you an idea of your what you will call it now, of your private IP addresses. So what's the answer here?
Is it A? I think it is A.
A or B?
Yeah, 192, 168 is that range of
A.
class C.
Let's look at it again, right? So here's what we looked at.
Okay.
So here's the range here. I'm going to use my snipper here, snip tool. So we go back to the question. And here is the snip tool. All right, so here's your range. You have this range here. You have this range. So which is it?
A.
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 Is B?
A.
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 A. Yeah, because A is 192.168.100.101. And here you have 192.168. So, yep. So it's got to be A. Let's see question 8. All right, so that's it right there. So IP addresses that are in the 192.168 range are private IPs. Also 10 range and 172.16 range, okay? So that's in class A, class B, and class C. You have some addresses there that are for private, and every private network can use those addresses. But the public IP is going to be different. All right, let's go on. All right, and Juman, next one is for you. Your friend Michael, so this is A here. Your friend is setting up a wireless network and ask you which security option they should choose to make the network most secure. You want to make your wireless network most secure. I think we talked about this, right? Is it A, B, C, or D? And Juman has disappeared. Okay, I know you want to try that. Question 9.
Yeah. It's this answer. Can I go with the answer directly, or you want me to read the question?
No, we read the question already. Basically, they want to know what's the most secure.
WPA2. I think it is WPA2.
Okay, they want WPA2. All right, so let's look at it again. All right, so WPA2. Okay, so right here, right? So it just tells you right there, WPA2 is the best of the options.
For wireless networks.
Yeah, exactly. Yeah, for wireless networks. And in fact, you don't even have to do it yourself. I mean, except you are a technician and you are setting it up, right, for somebody else. By default, it's always going to set to WPA2 by default, right? That's the highest level of security for wireless networks. It stands for wireless protected access. Wireless protected access. 2. And that's it again right here. So while you can create an open network connection, it's recommended that you use WPA2. That is your secure wireless options. I mean, security options, right? Okay, Lynn, number 10 is for you.
Which of following connectivity options
think-
give you the best mode?
Mobility. Mobility is mobile. That is, allows you to move around.
Oh.
So which option allows you to move around with your connection? You know what I mean? That's what the question is.
Yeah. A?
A, cellular.
Yeah.
All right, so let's see that. Cellular is like your cell phone, right? That's like your mobile phone. All right, so, okay. Okay, so let's look at this table. It's kind of easier, right? This table here. Common internet connection types and speeds. So when you look at cellular here, it says you can get up to 20 megabits per second when you're trying to download stuff. And it says it has a great range, supported by cellular providers, right? Let's see something else here. Okay, but look at here. Wired, see what it says here. Wired is more secure and faster, but wireless is popular because of its vastly superior mobility. So let's get something here. Let's just look at something here. Okay, see what it says here. All right, so if you can see what it says right here. Oh, this is too dark. I think what it's referring to is when you move between two devices, right? When you move between two devices, which one allows you to maintain a high level of connection, right? When you move between two devices. So it's referring to your wireless, right? You can move between two devices or two access points and still maintain very good connection. So I think what it's telling us is what it says right here. Wired is more secure and faster, but wireless is popular because of its vastly superior mobility. So you can move around easily, right? So I don't think it's cellular. I don't think it's cellular. Let's go back again to 1 second. I just want to get something here. I think the answer we found is probably the best option here. When we look here, yeah, that's the only place I can find that word mobility, and it refers to, yeah, right here. Wireless is popular because of its vastly superior mobility. So let's go and take a look there. What the answer is. What number is that again?
A.
Okay. All right, so now I'm totally confused because now it's telling us here that it's cellular networks, which is what I thought, but now I'm totally confused, right? So cellular networks give you the best mobility with a range of up to several miles. Even then, unless you go out of the range of a tower completely, you'll be handled or you'll be handed over to the next cell tower. Well, Lynn, you're correct.
Because wireless not go that far.
Yeah, but you see, but it doesn't tell us that clearly in the book. So it's a little bit confusing. But the idea is, how far can you go without wires and still be able to connect? I thought it was cellular, but then the book said wireless. So there you go. Cellular network. So the answer there is A. Okay, let's go back here and keep going. Okay, so that's cellular right here. Okay, is Anjuman back now? Anjuman, are you there? Your audio is not very. Your audio is not very good.
You hear me?
For some reason.
Can you hear me?
Yeah, it's not clear. All right, Arch, let's go to you, number 11. I can't get what Anjuman is saying, so let's go to Arch.
You need to set up a wireless network. Which standard will you use? Will give you the highest speed?
So wireless standards. Okay, so right here. So here, we talked about 802.11, right? 802 is the IEEE specification, right? The Institute of Electrical and Electronics Engineers, they are the group that puts together all the standards, right? So right here, they have 802.11 standards for wireless. So right, you have it here, right? Arch, A, B, C, A, B, G, N, and AC.
Yeah.
So the range is 120 meters for 5 gigahertz A type. So everything is quite here. I mean, this is a good table to look at. So when you look here, I guess 250 gives you the greatest range. You can go as far as 250 meters, and that's N. It gives you a maximum data rate of 600 megabits per second, indoor range of 70, outdoor 250. So I think back to that question.
I think AC.
So let's see. So
B.
which one? It looks like which one?
B. 802.11 AC.
Is it AC?
Yeah.
This is asking highest speed, right?
That is
Oh, it's asking
AC
what?
speed. So AC has 1300 Mbps.
High speed.
Yeah.
Okay, higher speed. So let's see that
Not
again.
range.
So highest speed. Where is the speed here?
1300
Data rate.
Mbps.
Oh, that's your data rate. Data rate, the speed. All right. Okay, you're right. I think you're right. So it's the speed. Yeah, the rate is the speed, right?
Yeah.
The rate of transmission or the speed of transmission. Okay, so all right. So 1300 megabits per second. On AC. Okay, so well, there's some kind of information here. It says 802.11n and AC. I think they're like the most common versions. AC routers are dual band, which means they support both 5 gigahertz and 2.4 gigahertz. That's 5G and 4G devices. Okay, so that's your answer right there. B, okay. Number 12, your friend Barbara needs to set up an internet connection. Number 12, in this scenario, which of the following options will give her the best speed? The best speed for internet connection. Alex, the best speed.
For the best speed.
So let's look at, there's a table here we can look at. Where's the table here? 1 second. Okay, here. So when you look at the speed here, right? So dial up, let me get rid of this here. All right, so look at all the speed here. You can see up to 20, 20, 25, 20, 1 gigabit per second, 50, 30, 56 kilobits per second. So if you grab a screenshot of that and go back to the question, and we see, oh, sorry, number 12. So the best speed. Yep.
Cable internet.
Fiber optic? No,
Yes,
fiber optic.
There's no
DSL option.
So it's choose 2.
Cable.
So cable and DSL. No, yeah, DSL.
Yeah, cable and, based on the options we have here, cable and DSL. I mean, most providers now use cable, right? DSL is mostly with the phone line. I don't think they use phone lines anymore. So if you're getting it from Verizon or Comcast, it's probably going to be cable internet. So let me tell you a quick story, and then we'll continue on Wednesday. So satellites, right? There is a. Has anybody heard of Starlink?
No.
Anybody heard of Starlink?
No.
What is that?
No.
Okay. Anybody heard of Elon Musk? Anybody heard of Tesla?
Yeah, Tesla. I heard Tesla. Elon Musk also, but I didn't remember.
Okay,
about
so Elon Musk owns Tesla,
Yes.
right? And
Oh.
Elon Musk owns Starlink, and
Oh.
Starlink is a satellite
Oh, okay.
internet service. For so if you live in a rural area, so basically you have a bunch of satellites, right? I think it's 2 T's. Is it 2 T's? Nope. 1 T, 2 L's. 1 T, 2 L's. All right. So there's satellites that are in space, right? And they send down signals, internet signals. If we look at Starlink here, all right, so if you see this info, it says, if you look right here, so Starlink is a satellite internet constellation. That is a lot of satellites, like thousands and thousands, right? Thousands of satellites, in space, right? And they communicate with ground transceiver. So if you have a satellite dish, right, you can receive the internet. If you're in a place where, it's so far away from town, there's no Verizon or Comcast or Xfinity, Fire, stuff like that, then Starlink was developed to help people in those regions, right? Starlink is a product of SpaceX, which is owned by, Elon Musk. So if you live very far away from town, that might be an option. It's not very expensive from what I hear. Let's see if we can find the cost. Let's see the cost of it. Oh, cost. Okay, so.
499.
Well, so that's like a one-time setup fee, right? A one-time setup fee. Let's go here. So that's Elon Musk. So let's see if we can find the price in here. Okay, look at it here. So many individual users are paying $99 per month, using a $499 bundle of the dish and the router. And then they're promising 100 megabits per second download. Let's compare that with what the book said about. So what we have for, let's go back here. Where is it? Okay. So when we compare that information with what we saw here, so cable is up to 50. Oh, look at that. So maximum download. So which is faster? Is cable faster or this thing from SpaceX?
SpaceX.
SpaceX.
What?
SpaceX.
Well, this is just a promise,
Promising, yeah.
right? This is just a promise. Look at what people are saying. Well, you can read about what people are saying. I don't think they're not getting this yet. It's just a promise. Like, okay, we're going to try to improve it. Let's see what people are saying here. Do we have any reviews?
$25 megabits per second.
Look at that. Okay, look at that, right? 25 is what people are getting. 25. So that's half of what cable gives you. So people are complaining. All right. Well, you can read more of that, if you want, just to give you that information about Starlink. But it's trying to help people that don't have much options, right? Give them something and improve on it gradually. All right. Okay, so this is cable and DSL. We're going to continue with the rest on Wednesday. Questions?
I have a question. What is the difference between router and a hub?
A router and a hub?
Yeah.
It's very different. We said that before. Your router moves information from LAN to LAN based on IP addresses, right?
Yeah.
The hub, or we say the switch, no longer the hub, right? The switch,
Hub.
the hub, which is now, a switch, does the same thing, but now this is what it does. It moves information from device to device in a LAN based on MAC address. So think about that. A router, it moves information between networks, different LANs. If you send an email from your network, the router is going to send that information along to the next network or LAN, right? Your switch, so we can say the router works publicly, works outside, right? The router works, we can say it works publicly. And your switch, we can say it works privately. The switch works in the house or in the building, right? When the router sends information to your network or to your LAN, right? The switch grabs that information and looks for the computer that owns that information, right? So think about it, Anu, as a letter comes into your zip code and then it has to be sent to your house, right? The router brings the message to your local area network, and the switch has to figure out, the correct computer to send that message to. So the router deals with the public information coming from the outside. The switch deals with the information inside the network, making sure that every device gets the message. Make sense?
Yeah.
So bandwidth sharing, how about the bandwidth sharing in the router?
Correct.
Well, there's no more bandwidth sharing. That was when we had the hub. The hub is now, you know, the hub is no more. the hub is dead. Didn't you attend the funeral of the hub? We send out invitations. The hub is dead.
Okay.
So what we set up here, the switch can read data, right? It can read the port number, it can read the MAC address, it can read the IP, and so it can send the message to the correct device, right? And it doesn't, and there's no bandwidth sharing, right? Does not do bandwidth sharing at all. Okay, Arch?
Yeah.
Yes.
Okay.
So I know you understand with the router.
Yeah. Good.
And the
Hub.
The hub and the switch. Well, no longer the hub, but the switch.
Yes.
Okay. Any more questions? Let's do the attendance. And if you have any more questions, let me know.